Okay, so here in this lecture we will discuss about multiplexer. In short, multiplexer is also known as MUX. Okay, multiplexer is also known as MUX. Now what is multiplexer? What is its definition? Multiplexer is nothing but a combinational circuit. Multiplexer is nothing but a combinational circuit in which there are 2 raised to power n number of inputs and only one output. Okay, and to select 2 raised to power n inputs there are n number of selection lines. There are n number of selection lines. Okay, the block diagram of multiplexer is this one. Is a block diagram of multiplexer. Here there are 2 raised to power n input, one output, and to select 2 raised to power n inputs there are n number of selection lines. So these are selection lines, n selection lines. These are n selection lines. Okay, 2 raised to power n inputs are there. 2 raised to power inputs are there, and accordingly we will get one output. Okay, so on the basis of n, on the basis of n, on the basis of small n, on the basis of small n, there are various types of order. There are various types of, such as 2 cross. In 2 cross order there are 2 inputs and one output. 2 input and one output. And when we compare this with the ideal, characteristic of n, then we find out 2 raised to power n equals to 2. Then we find out 2 raised to power n equals to 2. So what is the value of n? N will be 1. N will be 1. Okay, it means that in 2 cross 1 multiplexer only one selection line is there. Only one selection line is there. Clear? Now when we put n equals to 2, so at that time we will get 4 cross 1 mux. At that time we will get 4 cross 1 mux. In 4 cross 1 mux there are 4 inputs. One output. And when we compare it with the ideal structure of multiplexer, then we find out 2 raised to power n equals to 4. So n equals to 2. It means that in 4 cross 1 mux there are 2 selection line. Similar for the third case also. If we put n equals to 3, then at that time we will get n cross 1 mux, 8 cross 1 mux. Here 8 is input, 1 is output, and to select these 8 inputs, n equals to 3 selection lines are required. Okay, so this one is the ideal behavior of our multiplexer, that a multiplexer is a combinational circuit that consists 2 raised to power n inputs, and one output. 2 raised to power n input and one output, and to select one input from this 2 raised to power n inputs, we need n selection lines. Okay, This multiplexer is also known as data selector. The multiplexer is also known as data selector. Multiplexer is also known as data selector. Why it is known as data selector? Because it act as a switch. Because it act as a switch. Suppose suppose there are two inputs. So and at that time there is only one selection line. So this when this selection line equals to 0, at that time this upper switch will connect this input to the output path. So at that time this input will be transmitted towards the output. Okay, but when we put n equals to 0, so at that time first input is transmitted towards the transmitter, and at that time when we take n equals to 1, at that time this second input is transmitted from this side to this side. Okay, so we can also we can say this multiplexer is also act as a switch. Okay, so this one is all about multiplexer. What is multiplexer? Multiplexer require 2 raised to power n input, 1 output, and to select 2 raised to power to select only one input from these 2 raised to power n inputs, we need n selection lines. Okay, now we study 2 raised to power. Now here we study 2 raised to power 1 mux in detail. Now here we study 2 raised to power 1 mux in detail. First, step 1. First we draw block diagram of 2 cross 1 mux. In 2 cross 1 mux there are two inputs. I am representing these inputs as I0 and I1, and only one output is there, so I am representing it as CO. And to select one input we required selection line. So how many lines are required? Only one selection line is there. Okay, so this one is our first step. First step is that first we draw block diagram of multiplexer. Now after making a block diagram, what is our next step? What is our next step? Our next step is that after making block diagram we will draw truth table. We will draw what we will draw? We will draw truth table. Okay, so this one is our truth table. In truth table only one selection line is there, and accordingly we will find out output. Okay, so here the S is an input and we know that only one S is there, that's why only two combination will be possible, that is 0 and 1. So when this S equals to 0, so at that time when this S equals to 0, at that time when this S equals to 0, at that time this S naught will be transmitted in the output side. Okay, so at that time what we will get in the output side? We will get output side as I naught. Okay, but when S equals to 1, at that time this I1 will be transmitted towards the output. So what we will get in the output side? We will get output side as I1. Okay, so this one is our second step. First step is to draw the block diagram. Second step is to make the truth table. What is our third step? What is our third step? Our third step is that by using above truth table we will calculate equation. So what is the equation of output? Equation of output equals to I naught into S bar, I naught into S bar plus I1 into S, I1 into S. This one is the equation of our output. Okay, now what is the next step? Step number 4. What is our next step? Step number 4. By step number 4 is that by using the logic expression we will draw logic diagram. By using the logic expression we will draw logic diagram. Okay, so we will take S and also take its complement S bar here. Okay, now there are two minterms, this one and this one, so we need two AND gates. This one is the first AND gate and this one is our second AND gate. Okay, in first AND gate, first input is I naught and S1 bar, so this one is our first input and second one is S bar, so this one is our second input. Okay, so here I am connecting I naught. In the second AND gate, the one input is I1 and the another input is S, because another input is S, so I am connecting here. Now these two minterms are connected with plus sign, so to add these inputs we need OR gate. So this one is the OR gate. It will provide us output O. So this one is all about 2 cross 1 truth table. Thank you.